Hello, students. Welcome everyone to this new series where I'll be doing chapter wise previous year questions. Okay, I'll be solving all the questions which is required. I'll explain you the things conceptually also. So please keep watching these videos so that you score your good marks in coming board exams, that is 2026. What is very important while preparing for the subjective paper is how well you present. Okay, how well you present the concept. Just knowing the concept is not enough. Here, the presentation of the concepts are very important, and that is how you can get the good marks or maximum marks. And when it comes to the subjective writing or subjective paper or board paper, any board paper you may take. What is very important is it is not necessary that you study whole textbook, you will get full marks. It is not that way. Here you require a strategy. Strategy means, in simple words, what we say is that even if you refer to the questions of the previous years, you will get the whole idea about the chapter. What are the possibilities in that topic that could be asked? Okay. So I think I should go ahead with the topic without wasting much of your time. Okay, here first question. This question is taken from last year's paper, that is 2025, and the question is very straight. The first question, um, is state the Faraday's law of electrolysis. Now, here, if you see, there are two parts for this. One is stating the Faraday's law, and second is the numerical. Right. So this will have one mark, this will have one mark, and this numerical will have another one mark. Okay, because numerical is very simple. Usually numerical comes for 2 marks, and in that distribution is like substitution. Writing a formula is half marks, substitution is half marks, getting answer is half marks, and writing half marks. So that total comes to 4. But this question is very simple. That's why 1 marks for this. So state Faraday's law of electrolysis. So when you talk about the first law of electrolysis, the first law of electrolysis says that, like, when you write for the exam, it should be very systematic. Okay, it should be neat. So I'll use black color only, or will use some other color. I'll use red color for this. Uh, what does the law says? Law says that, okay, we'll write the law. Okay, the amount of chemical reaction, the amount of chemical reaction which which occurs at any electrode during electrolysis by a current is directly proportional to the quantity of electricity pass. Like, this law is basically talking about the electrolytic cell. See, there are two kinds of cell. One is electrochemical cell and the other is electrolytic cell. So electrolytic cell is where external electrical energy is supplied to run a chemical reaction, and electrochemical cell is the one in which chemical reaction takes place to run chemical reaction takes place and from which the electricity is generated. Now, electrolytic process basically includes processes like electroplating and like in which one metal is coated with another metal. So that deposition of one metal on the another metal will depend upon the how much of the electricity or the current is being supplied externally. So that is what is the law is. Now, second question, second part of this question, which is again for the 1 marks, is from the Coleridge law. Okay, so Coleridge law, they did not ask you to write the Coleridge law, but it is about the limiting molar conductance. Okay, it is the limiting molar conductance. This question, so I'll discuss. Uh, According to the Coleridge law, limiting molar conductance of the calcium chloride is given as lambda naught m, that is limiting molar conductance of the calcium 2 plus lambda naught m 2 times of Cl minus. Why I am writing it this way? Because whenever you talk about the calcium chloride, you put this into water, it is going to split as calcium 2 plus and 2 times Cl minus ions. So now what is the law? Like on what basis we are writing this formula? On what basis we are writing this formula? The law is very simple. I'll just paste the law over here so that our time is saved. Okay, just give me a second. So this law says that, yeah, okay. So Coleridge law says that limiting molar conductivity of an electrolyte. This is the electrolyte. What is the electrolyte? Calcium chloride is an electrolyte over here. Okay. Um, can be represented as sum of the individual contribution of the anions and the cation. This is the anion individual contribution and the cation. So this is what the thing is. And they have given the limiting molar conductance of the individual cation and the anion over here. So this is the thing. I'll delete this law so that we get a space over here. So answer is very simple for this. Um, this will be lambda naught m for the calcium is given as 119 plus 2 times lambda naught m for the Cl minus is given to be is equal to 76.3. This answer will come to directly 271.96. Now, this is the answer, very important. Siemens centimeter square per mole is the unit of this answer. So writing the unit, there is a marks for writing the unit. So finally, lambda naught m of this calcium chloride and writing the unit, there is a marks. Okay, writing the statement. See, this law which I have written over here is, it is directly taken up from the book, word to word. Whenever you write a law, you cannot write it in your own words. Okay, it should be presented as it is there in the book. Then only you'll get the marks, full marks. Next question over here is asked directly, that is draw a neat label diagram of hydrogen oxygen fuel cell by specifying the electrolyte and the electrode material. So just drawing a diagram is not enough over here. You have to know about what is the electrode material used and the electrolyte over here. So diagram is very simple for the hydrogen oxygen fuel cell. Um, that diagram is this way. This is the diagram which is there. 1 minute. Just a second now. Okay, this is the diagram which you are expected, and this is a fully, there are labeling to it. Very simple diagram it is, and very important, which you will miss. And there are chances many students don't do this, that's why they don't get a full marks. Same, when it comes to the skill part of the paper, they do ask a question mostly on the diagrams. They'll ask a diagram. When it comes to the cell, they'll ask the cell and they will ask you for the cell reactions, electrode, or the electrolyte. In this question, if you see, they are talking about the question is about okay, labeling is done. This is very simple diagram. On I know everyone will be able to draw this diagram, but mentioning about the electrolyte, that is very important. So what is the electrolyte over here? In this, it is clearly given in the NCRT that electrolyte for this is a concentrated sodium hydroxide aqueous solution. This is the electrolyte. And what are the electrode over here? Electrode, when you write the electrode, it is a porous carbon it is, porous carbon incorporated, incorporated, which finely divided platinum or palladium. Why platinum or the palladium? Just as a extra knowledge, you can understand that these are like a catalyst. Okay, if you write your answer, if you write present your answer in this manner, then you will get the full marks. That is 2 marks for this. You should write electrolyte, what is asked, and what is the electrode which is used. Fine? Yes. This is the next question. Here, this question is more of numericals. There are numericals. There is a logical question, and there is some techniques you should be knowing about the reaction. So this I'll just tell you first the marks distribution. This is over here written. It is written 4. 4 means 1 mark for this, 1 mark for this, and this carries 2 marks. Okay. So here the question, like they have given the data about the cell. They have said that E naught is of the silver is zero point 0.8 and E naught of the copper is 0.34. This is what the data they have given. And they have given certain concentration of the ions. Over here also they have given the concentration of the ions. And on the basis of this, first you have to write the cell reaction. You have to write the overall cell reaction. You have to write the second thing they have asked about the like whether it is possible to store a copper sulfate in a silver vessel. And last is they have told to find a E cell. This is based on the Nernst equation. This question is based on the Nernst equation. First, we'll try to handle the first part of this question. Write the net cell reaction. Right. So what I'll do is I'll take a fresh page for this. They have given E naught. Okay, what is the significance of this E naught over here? E naught of Ag plus getting converted to Ag means reduction potential. We are talking about the reduction potential of silver. How much it is? It is given to be is equal to zero point 0.8 volt. And the reduction potential of the copper 2 plus getting reduced to copper, yes, it is given to be 0.34 electron volt. 0.34 volt, not electron volt. This is the reduction potential. Now, what is the meaning of the reduction potential and how we should be using it? Okay. And to write a overall reaction, what are the necessary condition, necessary things we should be knowing? The first thing we should know before understanding the concept, we should know what is our requirement. Okay. We should know what is the reaction taking place at the cathode. We should know the reaction taking place at the cathode, and we should know what reaction will take place at the anode. Okay. Once we understand what type of reaction is taking place at the cathode and what is the reaction taking place at the anode, we will get the overall reaction. We can write the overall reaction very easily. But from this data, we should be able to identify which is cathode and which is anode. Right? First, we'll identify. Okay. So this is just for your understanding. I am writing how to identify. See how I'm writing. How to identify. This is not the thing which you have to write for the exam. I'm just writing this so that you understand how to identify cathode and anode from reduction potential value. Potential value. Okay. Answer is very simple to this. Answer is very simple. Um, electrode having higher reduction potential will will undergo reduction. Therefore, that electrode is what? Cathode. On cathode, reduction takes place. And electrode having lower reduction potential will act as what? Act as anode. Means oxidation will take place. I'll tell you the trick also how to remember this oxidation, which electrode, which. So over here, if you see, this is having 0.8 is higher value. So that's why this will act as what? This is our cathode. This is our cathode because reduction will take place. And this is our anode, right? So always remember that cathode undergoes reduction and anode undergoes oxidation, right? So we'll write oxidation half reaction or reaction at cathode or anode. We'll write first anode, the at reaction taking place at anode. At anode, what is taking place? Oxidation. Oxidation. You shouldn't be writing this short forms. You should be writing full, full like this. Oxidation half reaction. So copper will get oxidized because its reduction potential is less. So when copper gets oxidized, you will write this way. Copper from solid, it changes to what? Copper 2 plus. Now to change this to 2 plus, oxidation is what? Loss of electron. So this loss of electron is shown this way, 2 electrons over here. Now what happens at cathode? Cathode is reduction half reaction. Now, what is there on a cathode? It is a silver plus ion, Ag plus. Okay. So, whenever it is a reduction, you will show the positive signs, the ions which are there on the left side. Oxidation, you will be showing solid. There are some exception, but for you to solve this question, I would say this way. it will accept just one electron because there is just one positive charge, and this will change to what? This will change to silver solid. Earlier it was ion in a aqueous medium, water medium. Now it is changing to solid. Okay. Now you cannot write the overall equation because you need to make the number of electrons equal. So you will multiply to make the number of electron equal in a first and the second reaction. You multiply this by 2. Okay. And what do you get over here is I'll write the first anode reaction as it is. Anode reaction as it is. That is copper solid getting oxidized to copper 2 plus and 2 electron. And cathode reaction, I'm writing now I'm multiplying 2 with this. So I'll write 2 Ag plus 2 electrons changing to 2 Ag. The question was overall reaction. They had asked you about the overall reaction. Write a net cell reaction. Net cell reaction means overall reaction. So to write the overall cell reaction, see, you cannot crack this question by hearting every reaction. If you know the trick, you can do any question. You can crack any question over here. So what will happen over here is that this 2 electron and 2 electron which are on the opposite side of the arrow will get cancelled. So reaction will be this way. So what is there on the reactant side? Copper solid. This is the overall reaction which you are writing. 2 Ag plus copper 2 plus. This is aqueous. Huh? Here it is aqueous. This is also aqueous plus 2 Ag solid. And this is what I have written in a black color. That is the only answer which the examiner is expecting. So what you can do is rest of the things you can do this as a rough work somewhere and write this answer. Is that fine? So if you like the concept, you have understood the things, feels like you're understanding, you'll be able to answer well for your board exam by with the help of this video. Please give thumbs up to my video over here. I will love to see your thumbs up. Okay, so we'll take a next question, next sub question for this. Actually, what I observed is that last final reaction is not coming into the frame. Made some adjustment, and that is the actual answer. Now it is coming into the frame. Just have a look at it, and that's it. Okay. Next sub question, that is second question over here is it possible to store a solution of copper sulfate in a silver vessel? Means the question is this way. You have a silver vessel, you have a silver vessel like this. Okay. You have a silver vessel. The vessel itself is made up of what? Silver metal, chandi, right? And there is a electrolyte. Let's say there is a electrolyte which is it's a electrolyte which is there. Okay, in this, what electrolyte it is? It is copper sulfate. This electrolyte is what? Copper sulfate. What is the meaning of copper sulfate? CuSO4. Now CuSO4 means it is in aqueous medium. This is aqueous water medium it is. So this will split as what? Copper 2 plus aqueous and a sulfate ion SO4 2 minus. Means over here what is there? There is copper 2 plus ions will be there. Like in this case there is a copper 2 plus ions. And what is this in which it is in contact? Okay, this is the silver metal, right? Since the reduction potentials over here of the silver is higher than copper, silver is in this oxidation state. Ag, silver is in this oxidation, like zero oxidation state. It is in the metallic form over here. Okay. Now, do you feel that silver will undergo reduction further? or any kind of change the silver will undergo. Like if you want to say that silver, since silver is having higher reduction potential, it should surely undergo what reduction? Reduction means what? Reduction means reduction means what? Addition of electron, addition of electron. Now, is there any scope to add electron to this silver metal which is already stable and it is in the zero oxidation state? Who can accept the electron? If it was Ag plus, then it can accept the electron. This cannot accept the electron. So there is no reaction taking place at this on a silver. Okay. And copper will undergo oxidation, but copper over here is in the already in the higher oxidation state. How it can undergo more oxidation, right? So what will be the answer? Based on the reduction potential, it is very clear that you know you can write the answer this way. The question is it possible to store a solution of the copper sulfate in vessel? Answer is surely yes. Okay, it is possible. It is, you should write it this way, possible to be like to be more presentable, possible to store copper sulfate, copper sulfate in a silver vessel, in a silver vessel. Since you can write since silver has higher reduction potential, then what? Then copper. Silver will not get oxidized. Silver will not get oxidized. Silver should get reduced, but there is no scope for the silver to get reduced. If you write this way, you will get 1 mark for this. So last part of this question is okay. That is based on a Nernst equation. I'll take this on the top. So calculate the EMF of a cell at given concentration. Okay. They have said that consider 2.303 RT by F is equal to 0.06. Okay, I'll first illustrate the formula, the actual formula of the Nernst equation. Like basically it tells the relationship between the standard EMF, that is E naught cell, and the concentration. When the concentration is changed, how the EMF of the cell may vary. Okay, so Nernst equation is given this way. Very important equation when it comes to electrochemistry, Nernst equation. This equation is about this. It tells about the EMF of the cell, which is equal to E naught cell. E naught cell means when the concentrations of the electrolyte is 1 molar minus 2.303 RT by NF. Okay. Into log of concentration in anode half cell, concentration of anode half cell, I'll write, upon concentration of cathode half cell. Okay. So over here they have said that like further I'll write EMF of cell is equal to E naught cell. Like to be more simple form, whenever you do this, whenever you solve this value 2.303, You substitute the value of R, temperature is equal to like 300 Kelvin and Faraday's value 96500. You get the value to be 0.059, 0.059 upon N. Okay, like N as it is. Then you'll write log of concentration in anode half cell, or a concentration of anode half cell upon concentration of cathode half cell. The formula. Um, but they have told you to take 2.303 RTF as what? 0.06. So I'll change this formula slightly. Means my formula, what I'll be using is E cell is equal to E naught cell minus 0.06 upon N, and log of concentration in anode half cell upon cathode half cell. Okay. So here the challenges mostly student face is that you have to know that what is N for this. N is number of electrons transferred, number of electron transferred. See, for some set of the reaction, you can directly remember this N values, but if you know how to find this, no, you don't have to by heart any of these values. Okay. So you get this N value if you know how to write a half cell reactions. Then you can get this very easily. Or whenever you are remembering, no, or by hearting something N values for certain set of electrodes, that will also become very easy for you. Okay, that is what the N is. And second, these things, for this you require the overall reaction. Otherwise, you may make mistake in the, you know, in solving this. So to find N is what? Number of transferred electron. See, if you go to this question, if you go to the first question which we solved over here, we have N over here. Like I'll tell you over here, this is the first question we solved, and we wrote the half cell reaction for this. So I'm cancelling this two electrons you see. So the N for this reaction is 2 finally. And overall reaction is anyway over here, right? So what do we require? We require that N value, like no one will ask you for this. There is no marks for writing this overall reaction when you solve this. So if you directly write the N value, that is also fine. So what was that overall reaction? Overall reaction was this way. Ag plus copper solid. This undergoes reduction, and copper 2 plus aqueous. This is that reaction, right? Overall reaction. For this N is equal to 2, right? How to solve this? How to solve this? What happens when screen recording we are doing? That time the processing becomes little slow. Okay, so EMF of the cell is asked over here. EMF of the cell. So, and also one more thing I forgot to tell you. E naught cell I need to find. Okay. So challenges. These are the challenges while you solve the reactions. So first we'll find E naught cell. N anyway you know what is that? N is equal to over here. So N is equal to 2 electrons over here. If you see the half cell reaction, there I have cancelled 2 electron. N is equal to, I can write which is equal to 2. 2 electrons means 2. That is what the N value is. Okay. We'll find E naught cell. E naught cell is equal to, remember, E naught cathode minus E naught anode. What is the meaning of this over here? This E naught cathode represents reduction potential. Reduction potential of cathode, and this represents reduction potential of anode. So cathode was silver whose reduction potential was how much it was? Zero point 0.8, 0.8 minus anode was copper and its reduction potential was 0.34. Therefore, E naught cell over here I am getting to be is equal to 0.46 volt. These units are very important. So now let us find the EMF of a cell. EMF of cell is equal to 0.46 minus 0.06, n is equal to 2 over here. So log of what? Like I will tell you the overall equation. Overall equation was this Ag plus aqueous and a copper solid getting oxidized to Ag solid and copper 2 plus aqueous. So we have to take care of the stoichiometric coefficients also. So what do I write over here is the concentration of the anode half cell. This is anode half cell, or you can remember product upon reactant. So I'll write concentration of the silver raised to 2 into concentration of the copper 2 plus ion 1, because over here stoichiometric coefficient is 1. Down, this is concentration of Ag plus raised to power 2, and this is what concentration of the copper is 1. Like how did we write this? Based on the stoichiometric coefficient. This 2 I am writing over here 2. This 2 I am writing over here this. Right? So always remember anything in the solid, Ag solid is there, right? So its concentration is unity, is considered to be concentration is what? Unity. Unity means what? I'll consider this to be is equal to 1, right? Same way over here in the denominator, over here copper is solid. So I'll consider that concentration is equal to 1. Means how do I substitute over here? I'll write this way. EMF of cell 0.46 minus 0.06 upon 2 into log of concentration of the Ag. Ag is not given, but since it is solid, I'll consider this to be 1. Copper 2 plus. Copper 2 plus concentration is given to be is equal to how much? Copper 2 plus concentration is going to be 10 raised to minus 1. So I'll write over here. 10 raised to minus 1 raised to 1. Okay. Then what is the concentration of the Ag given over here? Concentration of the Ag given over here 10 raised to minus 3, Ag plus 10 raised to minus 3, and then whole square. And what is this? This is 1 the whole square. Okay. So I'll not write, I'll just solve this part. Okay. Just focus on this. I'm solving only this part first. Again and again I will have to write this equation then. So I'll write over here log of, you don't have to do this way, you can write all the steps. So log of what? 1 square is 1, 10 raised to minus 1 is 10 raised to minus 1. Down it is 10 raised to minus 3 square means 10 raised to minus 6. 1 raised to 1 is 1 raised to 2 is 1. So therefore this is equal to log of 10 raised to minus 1, and this is 10 raised to minus 6. So therefore, I can write this is equal to log of 10 raised to minus 1 and this is 10 raised to plus 6. Right? When numerator to denominator, its sign changes. So 10 raised to 5. So I'll write this as EMF cell is equal to 0.46 minus 0.06 divided by 2 log of 10 raised to 5. Now from the identity of log, that is log of a raised to x could be also written as x log of a. So this term log 10 raised to 5 which is there, I'll write this 5 log 10. So this is 0.46 minus 0.06 by 2, 5 into log of 10. So log of 10 to the base 10 is what? 1. So 0.46 minus 0.06 divided by 2 into 5 into 1. I'll write over here. I'll go to the next page. That is EMF of cell is equal to 0.46 minus 0.06 by 2 into 5. 0.46 minus 0.06, 2 and 2.5. When you solve this, this will come to 0.15, which is equal to 0.31 volts. Okay, that's why this question was very long. That's why this was for the 2 marks. Hope you have understood. Okay, before I go ahead with the thing, more questions. I would like to tell you some shortcuts about this or something to remember. Always remember this word. Like if you are getting confused between which electrode will get oxidized or which electrode will get reduced, always remember this loan word LOAN. L stands for left, means we represent this electrode in the left side while representing a cell. It will undergo oxidation, A for oxidation. This is anode, means anode will undergo oxidation and its polarity is negative. If you remember this, your job will be very easy. N for negative. So left oxidation, anode negative. So for cathode, it will be right reduction positive, cathode and the positive. Okay. One more shortcut about the, to find n value. Sometime it may happen that you may not have a time to, to write the half cell reaction, but sometimes full reactions are given. Okay, and from there you can handle this part. And how to find n in that case? See, if you have one electrode whose electrode is one in plus one, let's say there is plus 1, one electron, and other is in plus 2. So over here, n value will be is equal to 2. This is a trick which I am telling you. Okay. Then second, if it is one electrode is plus 2, other electrode is also plus 2, n will be is equal to 2, means number of electron transfer will be 2. If there is electrode which is one is plus 2 and other is plus 3, so over here this n will be 6. Okay, so these are the possibilities which will be there. Okay, you have to take care of, right? This will also help you to crack good amount of the questions. Yes, here is the next question. We'll read the question first. On the basis of given half reaction, okay, there are certain half reactions which are given over here. Okay, these are the half reaction. This is the only data they have given, and they have framed 3 questions on this. Total marks are 4, so maybe one for this, one for this, and two for this. Okay. So this reaction over here, this is also a reduction reaction. This is also the reduction reaction. And this is also reduction reaction. Okay. And the electrode potential over here, the values which are given, means it is not that, reduction reactions are given. This doesn't mean that both will undergo reduction. That's not possible in electrochemistry. Both cannot undergo reduction. One will undergo oxidation, other will go reduction. Right? It is as good as it is writing in sometime in some books or in some question. It is written, no? E naught is equal to, let's say, for the silver, Ag plus changing to Ag is equal to minus 1.66 volt. This is how it is same as writing this reaction. And reduction potential of the nickel is given to be is equal to E naught is equal to nickel 2 plus changing to nickel, which is equal to minus 0.25 volt. Represent the electrochemical cell. The first question is represent the electrochemical cell. I'll take this data. See. So first is represent the electrochemical cell. So how do we represent the electrochemical cell? So first we should know what is undergoing oxidation, what is undergoing a reduction, right? As I told you that lone, you have to always remember this. In an electrochemical cell, left side, this L represents left, O represents oxidation takes place, A represents anode, and N stands for negative, right? So whenever we represent a cell, we represent it this way. Now over here, out of these two, can you tell me, can you comment in this section and tell me what will undergo reduction and which will undergo, which electrode will undergo oxidation? Just think over this, take some time and tell me out of this, silver or nickel, which electrode will undergo reduction? I will love to see your comments. Students are commenting means what? Students are commenting means they are learning and you are in the full flow. You know, you know, remember that, uh, this thing, these small things are not only going to prepare you for what? Your board's exam. It will also help you if you are really aiming, seriously aiming for the JE or NET kind of exams. See, what is asked in a competitive exam, it is totally finally they ask something from the NCRT only. Okay, one question here and there will be there, which is, which you may not find in NCRT. You will say this is something which is very tough, but mostly everything, there also, everything will be from the NCRT. If you know these things, um, those exams will be also taken care of. So I am waiting for the comments. Let me see who can say that over here. Okay, you comment, I'll tell you what it is. So which will undergo oxidation and which will undergo reduction? Please check your answer even if you have not commented. So nickel 2 plus is having the reduction potential to be minus 0.25 and this is having minus 1.66. So which is greater value? Mathematically, numerically, this is bigger value. Minus 0.25 is greater than minus 1.66. So this is the one which will undergo what? Higher reduction potential. What I had told? This will undergo reduction and the obviously other one will undergo oxidation. So over here we are going to represent one which undergo oxidation on the left side while representing a cell. So while representing a cell, I am writing one which is undergoing silver. So silver undergoing, you will write silver solid. One line which represents the electrode potential. One line is drawn over here, single line, straight you have to draw. and then its oxidized form, that is Ag plus aqueous. Then we represent double line which tells you about the salt bridge. And what is undergoing reduction? Nickel 2 plus aqueous single line nickel solid. This is undergoing reduction. And this is what the cell representation, this is what is asked. Isn't it very easy to score this 1 mark for this? Left side, what you are writing? You are writing anode left side. This is anode and this is cathode, and this double line represents a salt bridge. Yes, that's it. Next sub question, that is second question. What is asked is among nickel and aluminum, which is better reducing agent? See, understand that reducing agent reduces reduces other and itself gets oxidized. So what they have asked is reducing agent, which is better reducing agent. Now if you see, the nickel will undergo reduction because it is having higher reduction potential. So nickel will go better reduction compared to what? If you compare, aluminum will not undergo reduction. If you treat them individually, not in a electrode cell, don't consider them as a couple in a cell. If you are understanding individually, since this has higher reduction potential, this will undergo reduction better and this will undergo reduction little less than what? Nickel, based on the reduction potential. When you couple them, this undergo reduction, other undergo oxidation. But individually, if you ask me, based on the reduction potential, this will undergo reduction better. Right? So they have asked which is better reducing agent. If this is the nickel which is undergoing reduction better, means it will oxidize other very easily. So it is not a very good oxidizing agent, right? A good reducing agent. It is better oxidizing agent, right? So among nickel and aluminum, aluminum is having lower reduction potential. So it will not undergo good, it will not um, undergo reduction, right? Not like we can say that um, nickel will be better reducing, nickel will undergo reduction better compared to aluminum, right? So in this case, reducing agent will be what? Better reducing agent. Better reducing agent will be aluminum. Okay, I will repeat this one more time. Nickel is having higher reduction potential, so it will undergo reduction when I compare that with aluminum. Nickel is having higher reduction potential, it will undergo reduction, that's why it will act as a better oxidizing agent. Okay. Aluminum will undergo oxidation, that's why it will act as a better reducing agent. So the answer for this one is aluminum. If you write this Al for this, you will get 1 mark. Next is calculate the equilibrium constant. Now how equilibrium constant? Again they have told to take this 2.303 RT by F is equal to 0.06. We'll start with Nernst equation. So what happens, sometime you may forget the reaction. EMF of a cell is equal to E naught cell minus, I'll write 0.06 by N log of concentration in anode half cell upon concentration in cathode half cell, right? So at equilibrium, cell doesn't give any potential. At equilibrium, EMF of cell is what? Zero. So I'll put this 0 over here and E naught cell minus 0.06 upon N. And this is called as what? Concentration of the product upon reactant at equilibrium is called as a equilibrium constant. Right? Like if you go back to your equilibrium topic, 11th standard syllabus, let's say there is a reaction like this. A nitrogen is there, 3H2 gas is there, and this gives you 2 moles of ammonia. How you would write the equilibrium constant? Kc will be written this way, no? Just telling you how the equilibrium constant we write. Concentration of the product raised to its stoichiometric coefficient upon N2, H2 raised to 3. Right? So this is how we write it. So log of Kc. Now if I write it this way, E naught cell is equal to 0.06 N log of Kc. Right? So therefore, formula becomes what? Log of Kc is equal to N E naught cell divided by 0.06. Actually, it is 0.05, but here you are told to take 0.06, right? So this is the formula. You are told to find Kc and not log of Kc. First, we'll find log of Kc. First, we'll find log of Kc. I'll go to the next page. Log of Kc. Okay. So first thing we have to know what is N. Yes, what is N over here? Can someone tell me? Someone can comment over here what will be N value because they have given the reduction potential. Question says that I'll not write the reaction, but I'll write the reduction potential. Al reaction is this way: Al3 plus and getting converted to Ag is minus 1.66 volt, and other E naught is what? Nickel 2 plus and nickel. This is equal to minus 0.25 volt. So over here n will be what? See, one is in plus 2 and other is in 6, right? 3. So n should be is equal to 6. See, if I write the overall, I'll write the half cell reaction, not required, but still I write the half cell reaction for you so that you understand the concepts better. See, once the concepts are strong, no, there is no fumbling. You will be so confident, no one can take your marks of the electrochemistry. All right. So this will undergo oxidation and this will undergo reduction based on what electrode potential value. I'll write the half cell reaction, the reaction which is taking place at the anode. See, I'm just telling you how to find this N. Okay, anode oxidation will take place. So nickel will get oxidized to nickel 2 plus and it will lose 2 electron. What will happen at cathode? Reduction will take place. That is aluminum which is already in a plus 3 will accept 3 electron to form aluminum, right? So to make the number of electrons equal, you will have to multiply this by 3 and will have to multiply this by 2. Now you will write this as 3 times nickel and then 3 times nickel 2 plus aqueous over here also. This is 6 electron. This is 2 times Al 3 plus 6 electron and 2 times Al. This 6 electron will get cancelled. N is equal to 6. Without doing this also we'll get it. And overall reaction will be 3 nickel. This is extra I am telling, not required so much for this question. You can find N directly by taking the help of shortcut. This is fine. We got the N value to be this. We want E naught cell also for this. What will be E naught cell? E naught cathode. E naught cathode minus E naught anode. So what is cathode over here? Cathode is aluminum which undergoes reduction, that is minus 1.66. Minus anode is what? Minus 0.25, which is equal to what? minus 1.66 plus 0.25. This comes to is equal to how much it will come to? Minus 1.41. Yeah, minus 1.41. One minute. What I have done? Cathode minus anode. This is undergoing reduction, no? This is undergoing oxidation. Sorry. I have a mistake over here, small mistake. Please excuse me for this. Cathode is what? Nickel is cathode. Nickel is cathode, right? So cathode is nickel is minus 0.25 minus 1.66. So minus 0.25 plus 1.66, which is equal to 1.41 volt. We got this also. Okay, therefore, log of Kc, log of Kc will be is equal to what? Log of Kc will be is equal to N is 6, E naught is 1.41, and this is what? 0.06. Very simple calculation. Log of Kc 6 into 1.41. Can I write this 0.06 as 6 into 10 raised to minus 2? This 6 and this 6 will get cancelled. Therefore, log of Kc is equal to 1.41 into 10 raised to 2, which is equal to 141. See, answer, this is not the answer. Answer is taking antilog on both sides. You want to get rid of this log, antilog of Kc, antilog of 141. So antilog and log will get cancelled. What remains is Kc, and antilog of 141 is 10 raised to 141. So this is the answer for this. That's it. This question over here is again straight question. State Coleridge law of independent migration of the ion. And second question they have asked is draw a neat label diagram for Lagrange cell. Okay, Lagrange cell, remember that this is also known as a dry cell. Okay, one mark for this and one mark for this, stating the law. So when it comes to chemistry, there is a conceptual understanding, and also you need to by heart. When it comes to laws and all, you have to by heart, like this law you take. You cannot write the law on your own. Okay, rest of things, if you are very good at, you know, writing those technical words in your own way or definitions in your own way, it's good. But laws always you should be writing on your own. So let's write this law. So what does the Coleridge law states? So we'll be writing Col Rausch. Coleridge law states that limiting molar conductivity of an of an electrolyte can be represented can be represented as the sum as the sum of individual contributions of the anion of the anion and cation of the electrolyte. This is a law. Like this is the things you have to write for 1 mark. Now draw a neat label diagram for the Lagrange cell. Now which diagram you will draw? Okay, if you go to see, there is one diagram. There is one diagram which is there in a textbook, which is kind of difficult to draw also. Okay, I'll just post that diagram over here. Okay, so this is that diagram about the Lagrange cell or a dry cell, one and same. Okay, this is a diagram. Okay, I will suggest that don't draw this diagram. Don't draw. If you are very good at, you know, very good artist, if you are very good artist, you can draw this diagram. But this simply will take your time, and it may look the like you may make this diagram little messy. Okay, don't draw this. Don't draw. It is not that it is wrong. It is correct, but don't draw this. What you have to draw is this diagram. You can draw a simple diagram like this. You can draw this diagram also. Draw this diagram. You see, this diagram over here is very simple. It is telling you about the electrode. Okay, it is telling you about the electrode, which is graphite rod. There is a electrolyte paste of NH4Cl and Cl2. It is a zinc. The external casing is the zinc anode, right? So this is the diagram you should be drawing, and you can get a good marks for this. Okay, okay, since the diagram is not very clear, my frame is coming. I'll just show it to you properly. Now the thing is clear. This is the diagram. This diagram you are not drawing. Not I'm deleting that. Okay, finally, what diagram you are drawing is this. This is the diagram you are drawing. Label diagram for full marks. This question over here, there are two parts of this question, total marks are three for this. Um, this is first question, I'll say. This is first, and this is second question. So first question, why copper spoon cannot be used to stir a silver nitrate solution? Like previously we have done about the copper sulfate, why can't be stored in a silver vessel, copper sulfate? Now over here, why copper cannot be stored? Or why it cannot be stored? Like you have a beaker, the question one I am solving. So you have a beaker, okay, in which there is electrolyte, in which there is a electrolyte of what? This electrolyte is of the silver nitrate, AgNO3. Means what will be there? There will be a Ag plus ions and a NO3 minus ion. Ag plus ion and like why we can't stir this using the copper electrode? Your copper electrode is this, or copper spoon. Let's say this is your copper spoon. Why we can't use this? Why we can't do this? See over here, if you see the reduction potential value of the copper is less, right? And the silver is more, right? Reduction potential. So E naught of Ag plus getting converted to Ag or E naught of the silver is greater than E naught of the copper. What will happen is this will undergo reduction, this will undergo reduction, and this will undergo oxidation. Now over here, copper is in what state? Copper is in the copper solid. Means if copper is in zero, it will undergo oxidation. And over here, silver is in what? It is in plus one. So it will also accept electron and it will also get reduced. So over here, there will be degradation of this spoon. Okay. And deposition of what? Silver ions, silver metal atoms on on the copper spoon. So what you are going to write for this? Finally, you have to write for this. Okay, you are going to write the answer this way. Copper spoon, copper spoon, write it this way. Copper spoon cannot be used, cannot be used to stir 1 molar AgNO3 solution because reduction potential because the reduction potential of copper is less than silver is less than silver. Therefore, silver will oxidize copper and copper spoon will partly get dissolved in AgNO3 solution. This is the answer you have to write. Second part of this question, calculate the EMF of a cell. Okay, different cell. This is the cell reaction, different ions they have given. Again, this is a question which we can easily solve based on what? Nernst equation. I'll write the Nernst equation, EMF of a cell. Here they did not tell any approximation. Like in the last example, they had told about convert or write that 0.059 as 0.06. Here there is nothing like that. So E naught cell minus 0.059 upon n directly I'll write log of concentration in anode half cell upon concentration in cathode half cell, right? So this is the formula which we'll be writing. Okay. So further, since there are marks for the formula, you can still write the better formula like this. If the question is for the 2 marks, understand half marks is for formula, half marks for substitution, correct substitution, half marks for correct answer and half marks for writing units. We should know this. 0.059 upon n log of product. These are the product. So that concentration of the chromium 3 plus ion raised to 2, concentration of the Fe raised to 3. Upon the reactant is what? Concentration of the chromium which is solid raised to 2 and concentration of the Fe 2 plus raised to 3. See this reaction, you don't have to struggle with half cell reaction, anything. Directly you can solve this very easily. Sometimes what happens is that just reduction potentials are given and just ions are given. You have to write the half cell reactions to know, overall reaction and to know n value. And here also n we can find very easily. You see plus 2 and plus 3, so n will be 6 over here directly. So I'll write, okay, E naught cell. We need to know before that what is E naught cell. There is minus 0.74 and minus 0.44. So E naught cell, first we'll write E naught cell is equal to E naught cathode minus E naught anode. Reduction potential of the cathode minus reduction potential of the anode. So over here, which is cathode, which undergo reduction, which has higher reduction potential, minus 0.44 is having higher reduction potential. So ion will undergo reduction, and from the reaction also you can understand it goes from plus 2 to 0 reduction. So minus 0.44 minus 0.74, right? So E naught cell will be how much over here? E naught cell is minus 0.44 plus 0.74, which is equal to 0.30 volt, right? This is our E naught cell. We know that N is equal to 6. How? 2 and 3. When these charges are there, these are the oxidation state of the participating ion. You consider that to be 6. If you want, I'll write the half cell reaction also. Not an issue. So I'll write over here EMF of cell is equal to 0.30 minus 0.059 upon 6 log of, I'll write concentration of the chromium was how much given, how much it was given. It was given 0.01, 0.01. Concentration of the solid is always considered unity. Okay, concentration of the solid is considered to be unity, which is equal to 1. Concentration of the Fe is how much? 0.1. 0.1 raised to 3, and this is what? 1 raised to 2, because chromium is solid over here. So this 0. What I'll do is I'll solve this part. Just pay attention, because again and again I am not going to write this. It will just simply increase the length of the video. So I'll write this as log of 0.01 is 10 raised to minus 2 raised to 2 upon, this could be also written 0.1 as 10 raised to minus 1 raised to 3, right? Therefore, it becomes log of 10 raised to minus 4 upon 10 raised to minus 3, which is equal to log of 10 raised to minus 4, and this will be 10 raised to plus 3, right? So log of 10 raised to minus 1, right? So how do we write this further? 0.30, 0.059 upon 6 into log of 10 raised to minus 1. 0.30 minus 0.059 upon 6 minus 1 into log of 10. Log of 10 is 1. So this minus and this minus becomes positive. If you cancel this, it approximately will become 0.01, and 0.30 plus 0.01, which is equal to 0.31 volts. This question is how much electricity in coulombs is needed to discharge 0.5 mole of chromium 3 plus ion. First, we'll understand what is this 96500. See, 96500 is equal to 1 farad, right? Now, what is the meaning of this? 1 farad, or we write this is equal to 96500 coulomb per mole is the unit of this. Okay, so it is a charge on 1 mole of electron. It is a charge of 1 mole electrons. Now, what is 1 mole of electron? I can also say this. It is a charge of 6.022 into 10 raised to power 23 electrons. Okay. So, how I can say this charge of 6.02 into 10 raised to 23 electron? So I will say that charge on one electron is 1.6 into 10 raised to minus 19 coulomb, and this is what 6.022 into 10 raised to power 23. When you solve this, no, this value will approximately come to 96500 coulomb per mole, because this is unit is per mole. 9650 coulomb per mole, 1 coulomb per mole. This is equal to 1 farad, right? If it was asked in farads, then you would write answer in farad. Coulombs, then actual coulombs you have to write. So, how much electricity in coulombs is needed to discharge 0.5 mole of Cr3 plus ions? Means we'll take this reaction. Discharge 0. So this is the thing. Cr3 plus will require 3 electrons? No. It is 3 moles of electron. This will change to what? Cr solid. This is so what does this represent? This represents 3 moles of electron. If this is 1 mole of chromium, right? Question again, going back to the question, 0.5 mole of Cr3 plus ion. Now over here 0.5 mole of Cr3 plus ion. You have to understand that. Now what is the meaning of this 3 moles of electron? Can I write this as 3 into 96500 coulomb of charge? Because 1 mole is equal to 96500 coulomb charge on 1 mole of electron. Understand this, huh? Charge on 1 mole of electron, charge on 1 mole electron is what? 96500. So charge on 3 mole electron will be is equal to 3 into 96500 coulomb, right? So over here, how much is this? 1 mole. So 1 mole chromium requires how much? It requires 3 into 96500 coulomb, right? Then 0.5 mole Cr3 plus will require X coulomb. You do the cross multiplication, write X into 1 equals 3 into 96500 into 0.5. This answer will come to 3 into 0.5 is 1.5 into 96500. Okay. So 1.5 into 96500. Answer is 144750 coulombs. Okay. This is the answer. That's it. This question, draw a neat label diagram of a and dry cell and write the cell reactions taking place at both the electrodes. Okay. Again, you know, dry cell diagram we will be drawing is this. For notes of the electrochemistry or any notes, you can always contact me directly on my number. You can just WhatsApp me. No issue. I'll send you the notes of any topic. Okay. Please feel free to ask for notes or any help you require with respect to chemistry. So this is graphite cathode and this, this is complete label diagram. But over here something extra is there. They have told you to write the cell reactions taking place at both the electrodes. So I'll write the electrode cell reaction. So you have to write along with this diagram, you have to write because this everything is for the 2 marks and this last question is for the 1 mark. Okay. So anode cell reaction is zinc solid will undergo oxidation, no, Zn2. This is very easy reaction. The anode reaction is very easy to remember. Cathode is something you need to by heart. That is MnO2 plus NH4 plus will accept 1 electron. It will change to plus. So over here, if you see, like this is the reactions you have to write. I'll just explain why first one is oxidation. Over here, if you see, this is in zero oxidation state. It is changing to +2. Here, this is in +4 oxidation state. This is changing to +3 reduction, right? Like if you want to find on this X -2 and -1, OH is -1, oxygen is -2, equal to 0. X is equal to +3, right? That's why it is reduction. So this is the thing you have to write. Second question, write any two advantages of the fuel cell. Advantages of the fuel cell is that not directly mentioned in the paragraphs of the NCRT. It is mentioned advantages. That's why it is very important. You refer your NCRT textbook, you read the lines of the NCRT textbook, like whatever, however, whatever number of the videos you watch, finally you have to come back to NCRT and learn from there. Okay, so advantages of fuel cell. The first advantage is that uh, fuel cells are pollution free or eco-friendly. Fuel cell are pollution free. And second, you can write, and fuel cells has efficiency of 70% compared to what? Compared to thermal plants whose efficiency is about 40%. That's it. Okay, here is the question, one more. So draw a neat label diagram of the lead storage cell and write the reaction taking place at both the electrodes during the discharging of the cell. So basically, if you go and see your NCRT lead storage cell diagram is very complex, impossible to draw, but you can draw this simple diagram anytime it is asked. So this lead storage battery cell is used in our automobiles, for the backup. So in which there is H2SO4 sulfuric 38% sulfuric acid is there as a electrolyte. Lead plates with lead oxide is there. Okay, coated with lead oxide. Normal lead plates are there. There's a positive ion, negative, positive electrode, negative electrode. These are the plates, the series they are connected. They have also asked the write the reactions. So you have to also focus on these reactions, which I have written over here, already pasted. So lead will undergo oxidation. If you see over here, this is in zero oxidation state. This will go to plus two oxidation state. The sulfate ions, because of the sulfate ion. And cathode will undergo reduction. If this is plus 4 over here, it is going to plus 2. Reduction of the lead is taking place. And you can somehow remember the reactions this way. If you know the reactions, half cell reaction, you can easily remember the overall reaction. Okay. Next question in the same, it is asked, write the product of electrolysis of the NaCl at the electrode, not related to this lead storage cell, but they are asking it independently. The answer would be for this, we can write that cathode, the reaction which is taking place, or the product of electrolysis at each electrode. Cathode, usually what happens is, um, water is reduced, water is reduced water is reduced to um, OH minus. Okay, OH minus and H2 gas. Like if 2 moles of H2O liquid is there, and if you are passing a current, if you are doing the electrolysis, what happens is that you get the hydrogen gas and 2 moles of OH minus aqueous. This is the thing which is happening at the cathode. And at anode, what will happen is anode, what will happen is chlorine ions are oxidized. Chloride ions, chloride ions are oxidized to chlorine gas. And write Cl minus aqueous changes to Cl2 gas by loss of two electron. You see this? Over here, chlorine is a minus one oxidation state. Here it is zero. So these are the things product of the electrolysis of the um, NaCl. Um, This question again, you see the question is repeated. State Faraday's first law of electrolysis. I'll not write this because already done at the beginning of the lecture. Calculate a state's standard Gibbs free energy of an electrochemical cell in which is following reaction is taking place. So Gibbs free energy relation is this way. Delta G is equal to minus N F E naught cell. You see over here, this is plus 2 and plus 3. So what will be the answer? Can someone comment? Answer will be directly n will be is equal to 6. Okay. If it was 2 and 2, then n is equal to 2. If 1 and 2, n is equal to 2. 1 and 3, n is equal to 3. So what is f? F, we know. F is already given 96500. What is E naught cell? E naught cell we need to calculate. E naught cell is E naught cathode minus E naught anode. What is cathode? Which undergo reduction, which is having higher reduction potential. This is the one which is having higher reduction potential. So it is, this is cathode. Minus 0.44 minus 1.66. So minus 0.44 plus 1.66. E naught cell comes to be is equal to 1.22. So over here I'll substitute. N is equal to 6, Farad is 96500, and E naught cell is 1.22. I'll discuss about the units also, don't worry. So over here, this value will come to, after solving this, 694800 units. Gibbs free energy is joules, right? But how to get it from here? Units of this. N is moles, Farad is coulomb per mole, and E naught cell is volts. Per mole and per mole mole will get cancelled. What remains is coulomb into volt. Always remember that 1 volt into 1 coulomb is equal to 1 joule. So this coulomb volt is equal to joule. So that's why this is the answer. Units are very, very important. Students, understand, if you are writing the correct answer, not representing a unit, your half marks will go just like that. Clear? So what you can do is, this is the way you can solve. This is the important part which you will be presenting in the paper. This is fine. You not sell if you are not writing. They're not presenting in the paper, fine. But formula, substitution, correct answer, and the unit. This should be there. Then we are going to get 2 marks, complete 2 marks for this.